All right, welcome back. And I want to believe that most likely you would have seen the question on your screen before. And if this is the first time that you are seeing this question, it might look so ambiguous, but then I'll be exposing you to an approach that is so simple to comprehend. And this question is so technical to such an extent that we need to bring together a lot of concepts in order for us to arrive at the answer. So let's just follow accordingly so that you get everything that is in there. Now let me take it to my whiteboard quickly. We are to find the probability that a number chosen between 100 and 999, 100 and 999, both inclusive. So we are to find the probability that at least one of the digits will be zero. So what do we need to do? Let's get started. Now the first thing is we have the numbers from 100 to 999. And of course, you know that in order for us to deduce probability of range of numbers, the first thing we have to do is we need to get the total number of possible outcomes. And in this case, it will be a very tedious effort for you to start counting from 100. Of course, we're told that 100 and 999 they are both inclusive. So if you want to start counting from 100, 101, 102, up until 999, might take a whole day. So how do we go about finding the number of terms that we have between 100 and 999? So what we do is, of course, we were told that it's very important for you to know that that term integer that was specified in the question is actually very important information. So since we're only considering integers, so it means that the numbers that we are looking at, they are whole numbers. So from 100, 101, 102, up until you get to 999. So we are only considering integers. We are not interested in the decimal. So that being said, it means that from here we can actually see that this is arithmetic progression. And if you don't understand the concept of AP, I think is also worthy for you to find a way of learning it. But for the sake of this lesson, let me just say a little bit about AP. This is arithmetic progression, and we can say that the difference will be 101 plus 100, which is 1. So that's our common difference is 1. And in this case, our first term A is 100, and the last term is 900. And don't forget, what we want to do is we want to find the number of terms between 100 and 999, 100 and 999, both inclusive. So now we have our A, we have our L. So we have to find the number of terms which is unknown. So we'll be using the sum of arithmetic progression, and there are two formulas for that I'll be using in this case. So now we have S equals to n over 2. When we are dealing with AP, we have S equals to n over 2 A plus L. Then also we have S equals to n over 2 into bracket 2 plus n minus 1 bracket. Now this first formula, we can use this first formula when you have both your first term and your last term. And in this case, we have our first term to be 100. Our first term is 100, which is, and our last term is 999. So we can find, our aim is to find our n. So let's substitute these values in both equation 1 and equation 2. So when we do that in equation 1, we have S equals to n over 2 into our A is 100 and our L is 999. So this will then give us n over 2 into, when you sum 100 plus 999, that will give us 1099. So let's remove this form of this equation. Let's call this equation 3. Then also we can substitute A and L in this particular equation. So when we do that, we have S, sum can also be n over 2 into our A is 100, so we have 200 plus, that's when you multiply by 100, plus n plus 1. And don't forget our D, which is the same as the common difference. We're able to calculate that to be 1. So our D is 1. Now, the idea is that we use these two formulas to find the sum of this arithmetic progression. Now, if the sum, using the last term now, the sum is n over 2, 1099, then using the other formula, the second formula, we have the sum to be this. So that means we can equate both equation 3, let's call this equation 4. We can equate both equation 3 and equation 4. And when we do that, we have n over 2 into 1099, which is equals to n over 2 into 200 plus minus 1. Then we can now simplify to find our n. So this, automatically we take out this. Then we have 1099 equals to 200 plus n minus 1. And then we can find n. So when we collect like terms from here, we have 1099 minus 200 plus 1 equals to n. So if we simplify this, then we can now see our n equals to 900. So now we can say that the number of total number of outcomes that we're looking at, we got 900. So we have the number of outcomes will be equals to 900. So we've been able to get that. Now the next thing we want to get now is we want to get the possible outcomes. The question actually states that we should find the probability of having at least 10 when you put together all the terms from 100 to 999. So what's the probability of having at least 10? Now, in order for you to understand that statement, it's English. The first thing is at least 10 means that either we have 10, either 10, or we have two zeros. And even if we're having 10, there are actually two ways. Of course, we know that from 100 to 999, all the terms between 100 and 900, they will be three terms. We can't have more than 3 digits for all the terms. And here's what I mean. We can have 101, which actually has 10. We can have 102, 103, and all of them up to 999. There's no term that have more than 3 digits. That's the first thing. And apart from those that are having just 10s, we can also have 2 zeros. And even before we look at the ones having 2 zeros, from these digits that are having 10, we can have a different arrangement. We can also have 110, 120, and so on and so forth. In order for you not to get it confused, we need to take it one step at a time. Now let's consider 10s first. For 10s, I'll show you two ways. And let me show you the difficult way first before I now show you a much more simpler way to attempt this. Now for 10s, is that you have 101. Let's keep the first term constant. All the terms starting with 1 now. Is that you have 101, 102, 103, 104, 105, 106, 107, 108, 109, 110. For all the terms starting with 1. Not just this alone. Of course, we know that we can't have 111 because there's no 0 as part of the digits that we have there. So aside those ones, we also have 120, 130, 140, 150, 160, 170, 180, and 190. From here now, we are leaving terms having the first digit to be 1. Then the next one will be 200. But for those ones that have 1 as their first digit, let's count the number of outcomes that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this actually means that for outcomes having 1 as their first digit and having just 10s, we have 18 outcomes. We have 18 outcomes. for those ones. Now, from 100 to 999, we have how many series do we have? The first series we have is the one starting with 1, the one starting with 1, can also be the one starting with 2, the one starting with 3, starting with 4, starting with 5, 6, 7, 8, and 9. And I can tell you that once you're able to get the number of outcomes starting with just 1 alone, then you can just multiply, by the number of series that you are going to get when you do for the other ones. The one starting with 2 will also have 18 outcomes. The one starting with 3 will also have 18 outcomes. Likewise, the one starting with 4 up until the one starting with 9. So if you do that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So um, it implies that for those ones starting with either 1, 2 to 9, and just having 1 zeros, you will have 18 multiplied by how many now? 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplied by 9. And when you do 18 multiplied by 9, that will give you what? 18 multiplied by 9, 18 multiplied by 9. That will give you, this is 72. That will give you 162. Yes, 162. For outcome starting with 1 and having just 1 zero, so we have 162 possible outcome. But instead of going through the rigor of counting one after the like I showed you, you can simply use combination method to get the number of outcomes starting with 1. And let me show you how. If you have you want to get 3 digits A, C. Now the first thing is, we know that the first one, now for outcome starting with 1, the first one is already taken care of. This will be 1. Then we have 2 digits to choose from, out of these 2 now, of course, one of them will be 0. We know that already. And there are 2 ways you can get that. Of course, the first one is 1. Then either B or C must be 0. So it's either you have 1, B, and this other one will be 0, or it could also be 1, 0, C. Meaning that we have 2 possible ways of getting this arrangement. Now we have from 0 to 9. 0 to 9 to choose from, which is actually 10 digits. We have 10 digits already. Out of these 10 digits, 1 has been taken, meaning we are left with 9 digits. And out of the 9, we want to choose 2 out of the 9. So we'll do 9 combination 2. Not just that alone, out of 9 we are choosing 2. We also know that now choosing 2 is not enough. There are 2 arrangements that you can have. Then you can divide this by 2. So if you simplify this, we have 9 multiplied by 8. Okay, let's take it this way. We have 9 factorial divided by 7 factorial multiplied by 2 factorial. Then when you do this will actually give you 9 multiplied by 8 multiplied by 7 factorial divided by 7 factorial multiplied by 2 factorial. Since you take this out, then 2 factorial is 2, so 2 here 1, here 4. So then we say that 9 combination 2 is equals to 36. So when you do 9 combination 2 divided by 2, of course, that will give you 18. Instead of going through the rigor of counting one after the other, so we know that for outcomes where the first digit is 1 and at least one of the other digits is 0, you have 18 possible ways. Now that's just aside. So now we know that we have 162 outcomes for outcomes with just 1 0 as part of their digit. Now the other one is, because they said at least 1 0. What about you having 2 zeros? So because it's either you have 1 0 or you have 2 0. Now let me show you. So in order for you to have 2 zeros, of course you are looking at outcomes like 1 1 0 0, 2 0 0. This will just have just one arrangement. Either way, still the same. 2 0 0, 3 0 0, 4 0 0, 5 0 0, 6 0 0, 7 0 0, 8 0 0, then 9 0 0. So if you count all of this, you have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have nine possible outcomes. So then when you add these 9 possible outcomes to the 162 that we got for outcomes with just 1 0, we have 162.9. So this will give us 171. Therefore, required probability will now be, of course, you know that probability is number of possible outcome, number of possible outcomes divided by total outcomes, number of total outcomes. So if this is anything to go by, the answer will now be 1 divided by, of course, we're able to deduce that total number of outcomes that we are looking at is 900. So 171 by 900 will be the answer. So I believe you've been able to gain one or two things in this tutorial, and I'll see you in the next tutorial.